Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 1.7, Absolute Value Inequalities. Video 1, Less Than Inequalities. I'm planning on having 4 videos for this section, 2 of them about less than inequalities and 2 of them about greater than inequalities. And in each pair, we'll establish a technique, and in the second video, we'll look at some specific examples and some exceptions. So why don't we start by clarifying exactly what I mean by a less than inequality. Consider an inequality of the following form. We have an absolute value with some expression on the inside, which should contain the variable, is less than some number. This is what I mean by a less than inequality when it comes to absolute values. 1 second, folks. Sorry for the pause there. But whenever you have an absolute value inequality of this form, where you have an absolute value with an expression less than a number, then you can always set it up the same way. And it should be pointed out that the technique that I'm about to show you also applies if this says less than or equal to. All we have to do is put the or equal to everywhere through the process, and everything should be the same. All right, so let's just take a look at this and think about what this means. You may recall that absolute value actually means distance from 0. So let's start there. Recall that the absolute value of a number, let's widen this text box, measures the distance from the number to 0. So if we were to look at this expression up here, or rather I should say this inequality, and interpret it in terms of distance, what is it saying? What is it saying? Well, if absolute value measures distance, then what we're saying is that the distance of this thing, whatever it is, from 0 is less than this number. So in other words, this particular inequality is saying that the distance from the expression to 0 is less than that number. Let's see if I can get all this on one line. I don't think I can, especially when I do this, but I can do this. All right. So what would that mean visually? Well, let's draw a number line and see if we can put a visual to this. Let's say we have a number line. Let's see, go straight across here, and we'll drop 0 in the middle since we're going to be measuring distance from 0. And let's just pretend that whatever this number is here is somewhere down here on the right side of the number line. Now, I know what you're thinking. What if that number is negative? Well, we'll talk about that later. In fact, I should clarify, maybe I should go back into here and say that this is assuming that this number is positive. This number is positive. Actually, let's do this. Let's get rid of that. We'll start another text box, but we'll make it smaller font size. And we will say that that asterisk means that the number is positive. Because when it's negative, it means something different, which we'll talk about later. All right, so for now, we're going to assume that that number is positive, which means it would be to the right of 0. So saying that the absolute value of the expression is less than a number is saying that that expression can go no further to the right than where that number is. But if you're measuring distance from 0, that also considers the possibility that it goes to the left. So what number would be over here, the same distance to the left? Well, it would be the negative of that number. And I guess we could be a little bit more algebraically sophisticated and write a variable for the number, but let's just go with what we have here. All right, so if we're going to say that this expression, the distance from the expression of 0 is less than that number, that means that whatever that expression is has to be in the middle here somewhere. So our expression has to be somewhere in this range, somewhere between negative number and positive number. Again, we're assuming the number is positive on its own. Well, that's just a double inequality, if you will. In other words, the inequality that goes with this picture is as follows. We can say that, excuse me, we can say that the negative of the number has to be less than the expression. I'll fix that. because in this picture, this negative number here is to the left of the expression, since the expression is somewhere in the middle, and therefore the negative number is less than the expression. But at the same time, the expression has to be less than the positive version of that number, because again, citing the same reason, this expression is to the left of this number, which means it is less than that number. So basically, the expression has to be between negative number and positive number. So what does this mean? This means that the inequality absolute value of some expression is less than a number is equivalent to the following. Let's see if we can space this out a little bit better. That's about as good as I can do. Get my picture out of the way. And we'll center this just because it looks better there. Now, what's the advantage of having rewritten the inequality, rewritten this inequality? What is the advantage of rewriting this as this? And the answer is the second one we've solved before. It's just a double inequality. So that's going to be our setup to solve an absolute value less than problem. Absolute value of some expression is less than a number. We're going to rewrite it by taking that expression. So we're going to take this expression here, and we're going to put it between this number and its opposite. Turn it into a double inequality and then solve it from there. So let's take a look at a real quick example. Solve the inequality. Write your answer in interval form. Draw the solution on a number line. And the inequality is the absolute value of x plus 3 is less than 5. Now, you don't have to draw what I'm about to draw every time you see an absolute value less than inequality, but this is just to put a visual to this specific problem. If we were to draw a number line and put 0 in the middle, what this inequality is saying is the distance from 0 to that expression, because that's what absolute value measures. The distance from 0, excuse me, to x plus 3, whatever that may be, is less than 5, which means x plus 3 cannot go further than 5 to the right of 0, nor can it go further than 5 to the left of 0. So that x plus 3 has to be trapped between these two numbers. As a double inequality, it would be written like this. -5 is less than x plus 3 is less than 5. Again, that's because the x plus 3 is to the right of -5, but to the left of +5. Ideally, you want to be able to go from here directly to here, because that change is what turns it into a problem that we know how to solve. If you want to draw the number line in between to emphasize the distance concept, you can. But again, going from here to here is the move I would like for you to have down. And then finishing this is pretty easy. All we have to do is subtract 3 from the middle. But in a double inequality, whatever we do to the middle, we do to the left and the right. And we would get -8 on the left, less than, the 3's would cancel in the middle, leaving the x, less than, and then 5 minus 3 on the right is just 2. As a number line, the solution will look like this. Here's -8, here's +2. And we want to shade in between, because that's how we shade a double inequality. And we'll use parentheses because it says less than, not less than or equal to. And the interval would be parentheses -8, comma 2, close parentheses. So it's not really that difficult, especially once you get to this juncture here. Once you get the inequality written as a double inequality, in other words, going from here to the other green box, it's a pretty straight shot to the end. I want to give you one to try, so let's see what that problem is. Solve the inequality. Write your answer in interval form. Draw the solution on a number line. The absolute value of 2x minus 7 is less than or equal to 19. Pause the video and give it a try. Yeah, pause the video and give it a try. Be careful, made a subtle change to it that you probably caught on to. Just think about how that will affect your answer. All right. Did you try it? If you didn't, why didn't you? You should practice doing the problem before I do to see where your strengths and weaknesses are so you know what to improve upon. All right, I'm going to do this one by bypassing the initial number line, illustrating that 2x minus 7 is less than 19 spaces away from 0, because I want you to get acclimated to how to just set up the problem without drawing the intermediate number line. To set up an absolute value less than problem, you simply put the expression between the negative of the number and the positive of the number. And in this case, it's less than or equal to in both of them. This says that 2x minus 7 is between negative 19 and 19, which makes sense because the inequality, the original inequality, says the distance from 2x minus 7 to 0 is less than or equal to 19. Pretty straight shot to the end. Add 7 to the middle, to the left, and to the right to see what we get. Negative 19 plus 7 is negative 12 on the left, less than or equal to. In the middle, the 7's cancel, leaving a 2x, less than or equal to. And on the right, 19 plus 7 is 26. And then to finish solving for x, we'll divide the middle by 2, which means we divide both the left and the right by 2. On the left, negative 12 divided by 2 is negative 6, less than or equal to. In the middle, the 2's cancel, leaving the x, less than or equal to. On the right, 26 divided by 2 is 13. As a number line, we would simply shade between negative 6 and 13. That's how you shade a double inequality like this. Because it says less than or equal to, we are going to use a bracket on both the negative 6 and the negative 13. And in interval notation, it would be bracket negative 6 comma 13 close bracket. All right, in the next video, we're going to look at some situations where things can go a little bit funky, including what happens if that number is negative.